Hi everybody, this is lesson 95 on page 650. Today we are going to be learning about the volume of a right solid. We have already learned about figuring out the volume of a shape. Volume should be the base times the length times the height. So in other words, all three dimensions multiplied together. In this big shape here, if you imagine a stack of blocks put into this shape, we would know our base would be 1, 2, 3, 4, 5. Our length would be how deep it is. That would be 1, 2. And our height would be, from the bottom, would be 1, 2, 3. If we multiply those together, we would have 5 times 2, which would be 10. 10 times 3 equals 30. If our measurements were in, say, meters, then we would put meters cubed. When you do volume, you always put your dimensions cubed. That is a necessity. If the base of a solid is a polygon, because you won't always have wonderful rectangular shapes to figure these out, they're going to get more complicated. So if the base of the solid is a polygon, the solid is called a prism. And these are some examples of prisms. This one is a right square prism. This is a right triangular prism because it has a right triangle. And this one is a right circular cylinder, which is actually considered a prism for this concept. All right, so from now on when we talk about volume, we're not going to say base times length times height. We're actually going to say the area of the base times the height. And the difference in how we look at that is because with these prisms, we don't have necessarily a base and a length. They get a little bit more complicated. So we need to look at the area of the base, times the height. So what is the base exactly? The base is going to be the flat side that if at any point you sliced a knife through this shape, that it would maintain that shape. For example, let's just use a can of cranberry sauce. We've all probably seen cranberry sauce. It comes out looking like a big circular prism of jelly, basically. And if you sliced it along its side, let's say you took it out of the can and you laid it down, you would have this nice round jelly-like structure. And if you sliced a knife directly through here, if you took your knife and you cut directly through here and went down, there's my little knife, you would get a whole bunch of circles, circular little shapes. So your base is the actual circular shape. So in this case, the circular shape would be on top. So this is your base of the right circular cylinder. Likewise with the triangle, if you had this triangular prism and you sliced it, you would slice it along the top because that would give you a whole bunch of triangles. Therefore, the triangle shape is your base. So you figure out the area of that base and then multiply it by the height. So some of these problems will require you to think a little bit outside the box and turn the shape mentally in your mind to imagine what is the base and what is actually the height. And we're going to see some examples of that as we go through this lesson. All right, so let's look at example 1. I'm going to erase the big block here. Example 1 is on 651, and it says find the volume of a right triangular prism below. And dimensions are in centimeters, and they show two views in the book on this. I'm going to try to draw both of them. Okay, so I like to do, you can find it the same way either way, but in the first example, they actually draw the right triangle as we would imagine it. That would be 3, this would be 4. It does not matter what the slanted line is because in finding the area of a triangle, we don't use the slanted line. But then it has the 3D effect to it, and I know I'm not the best illustrator of this, and it has the 6 down here. So what you have to envision then, let's draw a little dots. What you have to envision then, if you took this shape and turned it on its end so that the triangular becomes the base, becomes the bottom, it looks a little bit more like the second picture, and that's going to be a little bit harder to draw. So bear with me. That will be the 4, that will be the 3. There's our square indicator. We go down and down, straight across, and bring this down, and we have our 6 over here. So essentially what we've done is we've taken this shape. Let's say you had a block that was this shape and you just turned it up on this side. Now it looks like this. So our triangle is our base, and our height is the up and down part here. And so first we need to find the area of the base, which is the 2 straight lines, and this would not, the slanted line, even though it looks straight here, we have to remember that over here it is the slanted line, so we don't use that one, which means we don't use this one. We only use the ones that have 3 and 4. So the area of this base is going to be 3 times 4. Remember, it's a triangle, so we divide by 2. And so that becomes 2 goes into itself once, 2 goes into 4 twice. That becomes 6. Then we take that and multiply it by the height. So 6 times 6 would be 36, and it told us it was centimeters cubed. Okay, that's how we do that one. So we're going to go ahead and go right into example number 2. And example number 2 is a right circular cylinder. All right, it tells us here's our cylinder, and whenever I think of cylinder, I always automatically think of a can of something, a can of food, or a can of something another that's canned, just to get the visual. So here's our can or cylinder. It says the diameter of the right circular cylinder is 20 centimeters. Let's pause right there. Diameter deals with the circles. Now this looks like an oval, of course. Imagine a circle that has been turned. I mean, you can imagine, you can get a can out and look at it on the circular end and then turn it to get this vision. So our diameter would be what goes across here, all the way across, diameter straight across, and that is 20 centimeters. And it tells us our height is 25. Height would be up and down, 25 centimeters. What is the volume? It says leave pi as pi, which means we are not going to multiply by 3.14 or 22 over 7. We're just going to write pi beside the number. So remember, when we do volume, we have to do area of the base times the height. So the area of this base, remember, area of a circle is going to be the radius squared. It's going to be pi times the radius squared. We're leaving pi as pi. Our radius is not 20. Our radius is half of this, of the diameter, which would be 10. So that would mean that would be pi times 10 squared. So 10 squared is 10 times 10. That's 100. We would write that as 100 pi. That's the area of this circle. Then we have to multiply it by 25. So if you multiply that by 25, figure all that out, you would actually have 2,500 pi. Tells us our dimensions are in centimeters, and volume would be in cubes. So we would work it like that. Okay, that's all the examples that they have in the lesson, but I am going to go ahead and do the problems in the lesson that have these, and that is going to be number 14 and I believe number 15. So number 14 says find the volume of the triangular prism shown. Dimensions are in millimeters. So let's go ahead and draw this out. Here's our triangle, and it says it's a right triangle. It has a little indicator there. It says it's 40 and this is 30. Let me make that look more like a 4. And our 3D effect goes this way a little bit, and this would be 5. Now you have to envision the triangle. The fact that it says it's a triangular prism means the triangle is your base. So our base, let's just deal with that there. So area of the base is going to be 30 times 40. It's a triangle, so we divide by 2. 2 into itself once, 2 into 40, 20. That comes out to 600. But we don't stop there. That's just the area of the base. We have to multiply also by the height. In this case, it's 50, because if we took this shape and turned it on its bottom so that the triangle is on the bottom, the height would be this line here, and that would be 50. So then we take 60 times 50. If we multiply that out, we would get 6 times 5 would be 30. Add your zeros, and you have 30,000 millimeters cubed. And that's how you do number 14 from the set. Let's go ahead and do number 15 as well. And that is dealing with a cylinder, which we had an example of that. It says the diameter of a soup can. Hey, there you go, a soup can. We're going to go ahead and draw our soup can. Everything Cylinder makes me think of soup can or can of food or some kind of can. The diameter is 6 centimeters. So remember, this is our circle turned on an angle. So the diameter is 6 centimeters. The height is 10 centimeters. Okay, what's the volume of the soup can? And it does say use 3.14 for pi. So let's remember, we find the area of the base first. That is pi radius square. Pi is going to be 3.14. Radius is going to be half of the diameter, which is 3. So 3 squared. All right, so we can figure this out. 3.14, 3 squared would be 9. If you work this out, you would get 4 times 9 would be 36. That would be 12, and that would be 28. We have 2 decimal places, 2 decimal places. So that's the first part. Now we have to multiply it by the height, which is 10. And I'm simply going to just add my 10 down here. Bring all my numbers down. Again, 2 decimal places, 2 decimal places. So we have 282.6. Dimensions are in centimeters. It's volume, so we have cubed. So 282.6 centimeters cubed. That's number 15 from the set. If you have any questions about the lesson, let me know.